Hi guys, so today we're talking about solving systems of equations using the elimination method. Elimination method really just does exactly what it says. We're going to eliminate something. In this case, we're going to eliminate one of the variables from our system of equations. Okay, we're talking about linear equations. So our first example, and I'll kind of explain what I'm doing as I go through these examples. Our first example, we have 7x plus 2y equals 13 and x minus 2y equals 11. The thing about solving using the system of, or solving systems using elimination method, you need to make sure that whichever variable you decide to eliminate has the same coefficient in both equations, and that one of them is positive and the other is negative. That way they zero each other out. With the elimination method, what you're actually doing is adding the two equations together. And so when you add the two equations together, you want to be able to eliminate one of the variables because it just becomes zero. So our first example, 7x plus 2y equals 13 and x minus 2y equals 11. If you look at our 2x, or excuse me, our 2y and our negative 2y, they are the same coefficient. They're both a 2. One's positive and one's negative. So when I add those two y's together, they're going to zero out. Okay, so those become a 0. I'm adding 7x plus 1x, and I'm going to get 8x. And on the other side of the equal sign, I'm going to add 13 plus 11 and get 24. And then I'm going to divide both sides by 8 so that x equals 3. And my next step is I'm going to take that 3 and plug it into one of the original equations for the x and solve for my y. I'm going to use the green equation, and instead of x minus 2y, I'm going to say 3 minus 2y equals 11. And I'm going to solve this equation for y. So I'm going to subtract 3 from both sides. I have negative 2y equals 8. We'll divide both sides by negative 2. And we get y equals negative 4. So the solution to my system is at 3, negative 4. And when we write our solution, it's always in x, y order. Even if we solve and get y first, in the solution point, it will always come second. Okay? So this was an example of a system where we could just straight up add our two equations together. Okay? Sometimes we have to do a little work to get to where we can eliminate a variable when we add our equations together. If you look at this example, 6x minus y equals 11 and 2x plus 3y equals 7. It's going to be really easy to get rid of either my x or my y, but in order to do that, I have to multiply one of my equations. If I want to get rid of my y, since they have opposite signs, then I would need to multiply that top equation by 3. That means everything in the equation gets multiplied, not just the y. If I want to get rid of the x, I need to multiply the bottom equation by negative 3, okay? And that way it would get rid of the x's. Just because the y's are already opposite signs, I'm going to multiply the top equation by 3. So my top equation, when I multiply everything by 3, I end up with 18x. And then 3 times negative y gives me a negative 3y. And 3 times 11 gives me 33. So essentially, I'm distributing that 3 to the entire equation and not just one side or the other. Okay. If I don't distribute it to the entire equation, it completely changes the value of the equation. everything gets multiplied. All right, I'm just going to rewrite that second equation, the bottom equation, because we didn't have to multiply anything to it. And I can go ahead and add these up. So once again, now my negative 3y and my positive 3y are at a point where when I add them together, I'm going to get 0. 18x plus 2x is going to give me 20x. And 33 plus 7 is going to give me 40. And now just divide by 20 so that x equals 2. Now I could take that 2, substitute it into either of my original equations. Just because I like smaller numbers whenever possible, I'm going to substitute it into the green equation, into the bottom equation. So 2 times 2 plus 3y equals 7. I will have 4 plus 3y equals 7. We're going to subtract 4 from both sides. So 3y equals 3. And then we're going to divide by 3. So that y equals 1. And our final solution is at 2, 1. Again, this is x, y order. Okay. Just when we solve systems of equations, we have different methods that we could use. We could solve them by graphing the two lines and looking at where the lines cross on a graph. We could solve it by creating a table for both equations and looking at where the y's are the same, or the y values are the same for the same x. And then, or we could do a substitution method where we get one equation, we isolate a variable, and then we substitute that equivalent expression into the other equation. But elimination is basically straight up adding them together. We want to make sure that the numbers are the same, so we get an equivalent equation. But personally, this is my preferred method. I like elimination. Okay, there's fewer ways for me to mess it up, and so I really like elimination a lot better. For this one, you notice that we really can't multiply 5 to give me a 3. We can't multiply a 4 to give me a 9. And if we look the other way, we can't multiply 3 to give me 5. We can't multiply 9 to give me 4. So we're going to have to multiply both equations here. Okay. Just for grins and giggles, let's get rid of the x this time. So I need the x's to be the same number. So I'm going to make a little note to myself. I want to eliminate my x's. And so I want to look for the least common multiple of both 3 and 5. What number do they both multiply into easily, or the smallest number do they both multiply into? And in this case, it is 15. So I'm going to multiply the 5 by 3 to get 15. I'll multiply the 3 by 5 to get 15. And I'm going to make this a -5 because both 5 and 3 are positives. I need one of them to be a negative. Okay. I'm going to move my little notes, or I'm going to go ahead and erase my little notes because I need to multiply now. All right. So I'll move them down here. Eliminate x, and our least common multiple was 15. Okay. So for our first equation, 3 times 5 gave us a 15x. 3 times a 4y gave us a 12y. And 3 times 30 gave us a -90. It's a -30. So 3 times -30 gave us a -90. For our bottom equation, Negative 5 times 3 gave us a negative 15x.